starting with right here, and we will be starting it from bandwidth. What is the meaning of bandwidth? Okay, because that is the problem which we were seeing in the previous board also. I think we all understood this, but if we do not, just try to pay closer attention here, right? We all know that in 1 byte, and if I write 1 byte, the B is going to be capital. 1 byte is going to have 8 bits. There is no problem with respect to this. We all know about it, right? If we say 1 kilobits per second, and it is not kilobyte. If I say small b, it is bit. If I say big B, it is byte. So when we talk storage, when we talk hard disk space or something, we call this as a 2 terabyte or 5 terabyte or maybe 64 gigabyte of space. Here, basically, this is gigabyte, right? But here I'm talking about network speed, interface speed. It is going to be in bits per second. If I say 1 kbps, it is going to be 1000 bits per second. If I say that my router is having 1000 bits per second speed, right? The meaning is just simple that here on this wire, my router can place 1000 bits in 1 second. If I say 1 Mbps, it is going to be 1000 kilobits per second. If I say 1 Gbps, it is going to be 1000 million bits per second. If I say 1 Tbps, it is going to be 1000 gigabit per second. These are really basic things, but I want that we all should be on the same page because we will be using them when we will be using our tools, right? QS tools. So what is happening here? I have a router right here, and I have this interface of the router. And I am saying that this interface is having 10 million bits per second. The meaning is just simple, right? In 1 second, this router can put 10 million bits. What is the meaning of 10 million? After 10, there is going to be 6 zeros, bits per second. And people generally ask, what is the meaning? What is the difference between when you say bandwidth and when you say speed? Believe me, in this case, speed and bandwidth both are same. Because the meaning of the speed is how much bits can flow over this interface in 1 second, and that is going to be 10 million bits per second, right? If I talk about 100 Mbps traffic, then you can also understand the meaning of, if I say 1 Gbps, it means that 1 gigabits per second. This interface has the capability of this, and you all know that right now, or we can have the 100 Gbps interfaces also, without any doubt, right? Now, the point is that when we use bandwidth command and when we use the speed command, what is the meaning? See, the bandwidth command is actually used by many protocols for their settings, right? If you understand EIGRP well, then EIGRP, to calculate its metric, it is dependent on the interface bandwidth. And we can change this bandwidth of this internet so that these protocol understand that now the bandwidth is somewhat different than the default bandwidth, right? So although the speed of this interface is maybe 10 million bits per second, but if we want that EIGRP should be treated differently, we can change the bandwidth. But believe me, if we change the bandwidth using the bandwidth command, it doesn't actually change how many bits we are going to send over this interface. It is just the perception what EIGRP is getting, right? Even if we talk about OSPF routing protocol, if we change the bandwidth, OSPF metric is based on this bandwidth also, right? Okay. So how the routing protocols are going to perceive the bandwidth, and on the basis of they are going to calculate their metric, that is why we are going to use the bandwidth command. And it doesn't have any thing with respect to how many bits are going to be there on this interface. But the speed command is actually can change the speed of this interface, right? Suppose if we have 100 million bits per second interface, and if we give a speed of 10 million bits per second, then instead of putting 100 million bits per second on the interface, this interface will be putting just 10 million bits per second on this interface. This is actually the difference, right? And believe me, in quality of service, most of the problem can be solved by throwing more bandwidth. But the problem is, do we have that budget of having the more bandwidth? And there is going to be a lot of debate on this topic, and I would like to have you with. But for that, just give me one more class time so that we understand the meaning of classification and marking. So we have a question from Mr. Lias. Mr. Lias, please do ask your question. Go ahead.
Question regarding the speed and the bandwidth.
Mhm.
So suppose this, for example, if I ordered from the service provider 40 MB bandwidth,
Lias, your voice is little bit breaking. Is it for me or for everybody? Little bit choppy.
Is it okay now?
Yeah, it is echoing.
Okay.
Is it okay now?
Yeah, better.
So what I'm asking is, for example, my question is about the bandwidth and the speed. So from a service provider, say I ordered a 40 Mbps bandwidth, which they will be restricting based on the TOS. But their office speed will be 100 Mbps. So how will be that difference? It will be still, it will be on the
Again, little choppy voice. I get this much of the thing. For example, suppose we have this router, and this router is connected to service provider, right? And the service provider, suppose I have here 100 Mbps of the bandwidth on the interface because it is a fast Ethernet interface. But the service provider is saying that you can get maybe 256 kbps. Is it your question?
Yes, that's correct. My ordered bandwidth is 40 Mbps, but still my speed will be based on the Ethernet, right? So how will be that?
Yeah. So this is, Lias, it is going to be explained when we talk about shaping portion. And in this case, basically, whatever the service provider is saying that your committed information rate is this much, 256 kbps. And my problem is now I have 100 Mbps bandwidth right here. Means the speed which I am on this interface 0/1 is 100 Mbps. It means that if many packets come, I can put them on this interface at this speed or this bandwidth, because here the speed and the bandwidth is going to be same. Now my problem is going to be I cannot put more than 256 kbps. Otherwise, the service provider guy here will be chopping it, or will be not chopping, will be discarding my packet. So instead, I have 100 Mbps of the bandwidth or speed on the 0/1 interface, but this router has the capability to delay this process of putting the data on this interface, right? Such that 256 kbps will be out all the times. If that is the case, then we will be doing a shaping. And I haven't included it, but definitely, Mr. Lias, I will be talking about it. Just give me 1 or 2 classes. And this is the whole sole point of shaping, which we'll be introducing. Mr. Lias.
Okay, so it will be based on the port. It will matter what is the maximum speed. It will be based on the bandwidth, and the accordingly we can shape the ports.
Yeah, but your voice is really bad. I'm not sure, but
Okay, fine. There's some network.
Yeah, some network issue. Yeah.
I got it.
Okay. So anybody else? I think Mr. Rohit or Rajit has raised the hand, but now I see the hand is down. Okay, perfectly fine. Let's go to the next board where we will be talking a little bit more about bandwidth. Okay. Okay. So same problem, right? Whatever we have right here 2 packets, packet number 1, packet number 2, and this packet number 1 and packet number 2 uh, is actually my packets from critical application, and these are the packets from Bahubali movie, right? And it happens to be that these messages are right there, and this is the one which is basically came later. Right now, suppose I have a 10 Mbps of uh, bandwidth, right? What can I do is that suppose from 10 Mbps I can increase this bandwidth from 10 Mbps to 100 Mbps, right? Suppose previously this interface was only supporting 10 Mbps. Now what I have done is I have taken some other interface which is having 100 million bits per second, right? But now my question is that, see, we have increased the bandwidth from 10 Mbps to 100 Mbps. Is it going to solve this problem? There is no doubt about it that if we have all this traffic, right, which can be immediately sent over this interface without any delay, then I think my problem is solved, right? If I do a 1 Gbps, then of course all the packet will be going. But still, I would say when I see this packet, suppose let's take an example that this packet is having 125 bytes of data, suppose, right? It means that it is having 1000 bytes of data. Let's take an example, and it is going to be really, really interesting mathematics, right? 1000 bytes. And now this guy, right, on this interface, if I talk about it is 100 Mbps of interface, right? Then in how many seconds I can place this 125 bytes of data right here, right? So right now my interface speed is 100 million bits per second. It means that I can place in 100 million bits in 1 second. There is no doubt about it, right? If I want to place 1 bit, how much time I'm going to take? 1 second divided by 100 million bits means 1, 2, 3, 4, 5, 6, right? And if I have to place 1000 bits, then it is going to have 1 by 100, 10 means 6 zeros into 1000. And if you divide it, you are going to get something like this number, right? So overall, if I see, and suppose this number comes to be say 0.001 millisecond or okay. So basically there are lots and lots of zeros. Let's try to understand with a simple example, right? Instead of calculating with 1000 Mbps, we will be calculating using 1 Mbps, right? It is going to be simple. Just put some of your brain right here. I am saying that in I can put 1 million bits, means 10 to the power 6 bits in 1 second. If I want to put 1 bit, it is going to take 1 upon 10 to the power 6. There is no doubt about it in this much second, right? If I want to put this complete packet of 125 bytes, which is 1000 bytes, it means that I have to do for 1 bit this much. For 1000 bit, I need to multiply this with 1000, right? It is going to give me 1 upon 10 to the power 3, right? Seconds. It means that it is 0.001. And by the way, if I divide a second by 1000, it is going to give me 1 millisecond, right? So 0.001 second is going to be 1 millisecond. It means that if I want to put this 125 byte device for 125 byte packet onto this interface, I am going to take 1 millisecond of time, right? And if I have 500 such packets right here, after 500 milliseconds, these packet will get chance to just put on this interface. Are you agree with me? Right? And there is no doubt about it that if I increase the speed from 1 million to 10 million, this 1 millisecond is going to be 0.1 millisecond, right? I am increasing the speed. It means that I will be putting these messages faster on the interface, right? And if I go with the 100 Mbps, then it's 0.01, right, or 0.01 millisecond, I can put this entire message. So you can think that if I have to wait X milliseconds, right, when my interface bandwidth were a little less, I have to wait maybe a little bit lesser when I increase my bandwidth. So there is no doubt about it that if I increase my bandwidth, right, then the time these messages are waiting here in their turn, it is going to be a little less. It means that I will be getting more quality of service, right? Or I will be getting the experience way better as compared to when I have the little bandwidth right here. So from this example, if you get only 10% of those board, it is more than enough. What I want to say that if my interface speed is 100 million bits per second, the meaning is simple. The meaning is I can put 100 million bits in 1 second on this interface. This router has this capability, as simple as that, right? The more the bandwidth is, the more the capacity of this router to put these bits on interfaces. And at the end of the day, what exactly you are doing, if you want to send your data, you have to put these bits on the interfaces. The more the bandwidth, the more the bits you can place. If you can put the more bits on the interface, then this queue time, the time you spend in this first in, first out queue will be less. And if you are spending less time in the queue, it means that your experience is going to be good. So most of the time, whenever there is a problem, people say increase the bandwidth. And if you increase the bandwidth, that is what happened exactly, right? So I think we all understand the concept of bandwidth now. Let's talk about the other concept, which is delay. What is the meaning of delay? Delay is another interesting thing, right? So when Anjali sends a packet from source A, which is right here, and suppose the time is when she started this message sending is, I'm just taking an hypothetical example just to explain you. At morning 10 a.m., 50 minutes and 30 seconds, right? She started to send this message. The message reaches here. Switch does some processing over this message, and then it is going to send it over this interface, right? And the distance between this is maybe 1,000 kilometers, right? If that is the case, the packet will be moving into this WAN infrastructure, which is going to take this, where it is going to travel 1,000 kilometers and will be reaching here. So some time will be spent here, some time will be spent here, maybe XY, maybe this Z, maybe this A, and eventually the packet will be reaching here. So I am just saying at every hop, whenever you receive a packet, you are going to see it, right? You are going to take the forwarding decision because the switch, on what basis switch is going to forward this message? You all know it is going to forward this message on the basis of MAC address. It is going to match this MAC address with the MAC address table. It is going to take some time, although this is going to be very, very limited time or small time, but the time is going to be there. And we call this as a forwarding delay. The amount of time taken by a switch or a router in deciding how to forward this is your forwarding delay. Then, of course, you need to put this message or this packet over this wire, right? In accordance with whatever the bandwidth you have, right? And this is known as serialization. The meaning is at the end of the day, packet is just what? Ones and zeros. You need to put this packet over this wire. To move this packet ones and zero over this wire, this process is known as serialization. And to serialize, you need some time. That is going to be known as serialization delay, right? And the packet will be moving over this wire, although this wire is really small, maybe 5 feet, 6 feet, or even lesser than that. But this wire and this complete wide area network is 1,000 kilometer. To travel 1,000 kilometer, you will be needing some time. And suppose that time is, say, 0.5 seconds. This could be the case. And then this packet reaches here. If you consider all the time, suppose this packet reaches here as 10:50, 31 a.m., right? How much time it took? It took 1 second. In this 1 second, what do we have? We have all the delays: serialization delay, forwarding delay, and the WAN infrastructure delay, whatever we have, right? If we calculate all the delays, if we calculate all this time, right? Whatever the number we reach here, that it took total of 1 second. It is the network delay, everything is there, right? This number 1 second is known as the delay, the time it takes from the source to destination. Doesn't matter, and it is going to be a variable, right? If you have more devices in between, or maybe this 1,000 kilometers is 5,000 kilometers, then it is also going to be changed, right? Every host, every link is going to add some delay from source to destination, right? Can we reduce this delay? Of course, the first answer is going to be yeah, just increase the bandwidth everywhere, right? Means if we have lots and lots of packet, and if this guy is taking a lot of time in just serializing this packet over this link, we should increase the bandwidth, right? First solution is bandwidth, but bandwidth is not going to be always the correct way. We can have other mechanism, other quality of services tool through which we can definitely reduce the delay. The delay, one delay which I haven't introduced till yet is the queuing delay. The meaning of queuing delay is, you all know the first in first out process now. If we have a first in first out queue and we have Bahubali movies packet and then we have our packet, right? Then the amount of time we spend in this queue is again adding to my delay. At least I can remove this delay because this 1000-kilometer delay is fixed, right? Because this is means if you are using the optical fiber cable, you will be using this light. The light speed is 3 into 10 to the power 8 kilometer per second, right? And if you want to calculate the distance, how much time I'm going to take means 1000 upon 3 into 10 to the power 8. You can divide it and you can get the time in millisecond, how much millisecond it is going to take to travel 1000 kilometer if I travel from the speed of light. Interesting and simple too. Overall, there are multiple types of delay, maybe, which we can discuss in this next board. Some of them, at least some of them, right? So here I am just taking the same example, same router, Bahubali movie packets, which we have right here, and we have this business critical application packets, right? Of course, they are spending more time. If we have, now I've taken example of 100 million bits per second. What are the different delays we can have here? Number one is serialization delay, which we are talking about. What is the meaning of serialization delay? If I have 125 bytes of packet, suppose, right? And I want to put this 125 bytes over this here, it means that I would like to put 1000 bits because 1 byte is equal to 8 bit. If I multiply 125 with 8, it is going to give me 1000 bits, right? If I can place 100 million bits in 1 second, you can easily calculate how much time I'm going to take if I want to put 1000 bits over this, and this time, which is going to become across 0.001, right? This time is actually your serialization delay, right? The second one is your propagation delay. The meaning of propagation delay is if you have these two routers, and between these two routers you have, which we just discussed, maybe 1000 kilometer. Now I'm just giving whatever we just explained, I'm just giving them a name. If we have 1000 kilometer, right? How much time it is going to take my bit to travel from here to here at this point, right? This is known as propagation delay. If you are using optical fiber, the speed of light, with the speed of light, your bits are going to travel because at the end of the day, the light is traveling and light is carrying data, right? You can easily calculate it. And this delay is going to be fixed. Serialization delay is going to be fixed. Why? Because if you have 100 million bits per second interface, you have 100 million bits per second interface means you cannot decrease it, right? Maybe you can decrease it, but you cannot increase it. If that is the case, if you want to place 1000 bits, you have to take 0.01 milliseconds. If you have to send this bits over 1000 kilometer long link, you are going to get some minimum amount of time, right? But the third delay is known as queuing delay, Q-U-E-U-E, and queuing delay, right? These packets have to wait until unless all these packets have gone because they have come first and this is my first in, first out. This is my problem, right? Which we have discussed in case of delay also. So most of your queuing, most of the quality of service related issues, whatever we see is the bandwidth, whatever we are seeing right here in terms of delay, right? Because this queuing delay can be changed. It depends on how many packets you have at your front. Or maybe you do not want to obey first in, first out. Maybe you can create another queue and you can put your business critical packets into this queue, and there is somebody which you have instruct into this router that pick the business critical application queue first and pick whatever the FIFO you have later. This is what we are going to study in queuing. See, we are just understanding or trying to understand some of the concept with respect to bandwidth, with respect to delay. But at the end of the day, we just want to have less delay, right? So that our packet can move fast. And queuing through queue to create different type of queues, right? Which is one of the solution in quality of service, which is one of the tool in quality of service. But understand these terms. If you understand these terms, delay, bandwidth, packet loss, jitter, you would be good. Having said that, let's talk about over the next board. the new term or the next term, jitter. I think you have understood it. And in tomorrow's class, I will let you know that how jitter, delay, packet loss is going to affect some crucial traffic type, which is your voice traffic, which is your video traffic, right? Now, let's talk about jitter. Suppose this time Anjali is talking over IP phone. With whom? To our Mr. Rahul, right? Right here. If that is the case, this traffic is going from here to here over this 1000 kilometer link. Again, we started at 10 a.m., 30 minutes and say 31 second. And we reach here, suppose at 35 second. I'm just taking the hypothetical example, although 4 second is too much of the delay, which we do not want, right? So my first packet is going here and it is taking 4 seconds of time, right? Then Anjali sent the second message. The second message took, say, 6 seconds. The third message is again taking, say, 2 seconds, suppose. And you can see that there is a difference in the delay. First packet just moved in 4 seconds, then the 6 second, and the third is super fast at 2 seconds. The difference in delay is known as jitter. And believe me, jitter is not good for some of the application, specifically in case of voice. Jitter is not good. Voice need, my packet should be continuous. Maybe if the one packet is coming at 20 millisecond and the other packet difference between 2 seconds is 20 millisecond, believe me, it should reach at this 20 millisecond time difference. Otherwise, whoever is at the receiver side of this is not going to like it. He will be, he can whatever the voice he will be listening, it is not good, right? He can feel that difference. If this jitter value, which is difference in the delay, and it is changed, right? If it is too much of the difference, then whoever the receiver is not going to understand much. That is why some applications are really doesn't like these jitter values. And we can define it that if this much is the jitter, if this much is the delay, then this application is not going to work. Okay. So if I talk about the last thing, which is my loss, to understand packet loss, right? And how to, and definitely if I talking about jitter, the jitter can happen that if you need to wait for long in those first in first out queues. If that is the case, it is going to be a problem, right? Again, we can have some tools through which we can reduce the jitter. One of the important things, or one of the straight away thing, is just increase the bandwidth. If bandwidth is there, then we do not need to wait much in the queue, because if bandwidth is more, we can serialize that packet faster. But as I mentioned, bandwidth is not the solution of every problem, and I will be talking about it with a specific example tomorrow. But here, let's talk about the packet loss. Right? What is the meaning? So the packet loss meaning is that Anjali is again talking to Mr. Rahul, right? And Anjali is sending too much of traffic, right? Here we have 1 gigabits per second GBPS interface, and here, because this is my WAN side of interface, suppose I have 100 Mbps. And here I have too many users which are sending so much of packets here. And of course, this interface will not be carrying 1 Gbps of traffic, right? If this is full, then there is a problem. Although what we have in most of our router, that we use buffers. Buffers are just memories, right? Whatever I can send, I will be sending it. Otherwise, I will be store them in buffer. But these buffer are just the memory, right? And we do not have unlimited memory in this router. If that is the case, then this memory is going to be filled. If this memory is going to be filled, then we need to drop these messages. And if we drop these messages from the tail side, this is what is known as the tail drop, right? Suppose we have only one queue, FIFO, first in, first out. We were able to send some of the message, but because we were not able to send some of the message, these are in this buffer, right? And these are in the buffer, then and this buffer is also filled, what is going to happen? We will be tail dropping it. Whatever is coming next, we will be dropping it, right? But is this the right approach of dropping at the tail? Can we drop in some different manner? I think you understand, or you must have heard about WRED, which is weighted random early detection, or RED, which never comes into the production, which is random early detection. And this is closely related to your transmission control protocol. Believe me, understanding of transmission control protocol is crucial, right? Not with respect to only QoS, but with respect to some other things. I'm not saying that it is absolutely mandatory to know TCP well, but whatever the concept is required. For example, in TCP, we all know that if the packet is dropped, right, my window size is going to be half. I mean, whatever the amount of packets we were sending or amount of data we were sending previously over a TCP connection, if any one of my packet is dropped, I am going to reduce my window size. If whatever I'm saying is not making sense to you, it means that there is some problem with respect to the TCP concepts, but that is fine. Whenever we are learning about weighted random early detection in the concepts of queuing, we will be talking about little bit of transmission control protocol so that you can understand why at the first place we are doing WRED, right? So overall, packet loss is going to be a problem for some messages, right? For example, if Anjali is talking over a phone call to Mr. Rahul and there are continuously 10 packets dropped, right? Then there is a problem, right? Because whatever the message Anjali wants to give, she's not going to get. And if you understand that these voice over IP or the real-time protocol traffic, right? Whatever the application is running in the real time, they are running over a UDP protocol. If the message is missed, it is missed. And you can understand it, right? If you're talking to somebody over a phone, right? And if some of the packets are dropped, it doesn't make any sense to receive those messages or those packets after 1 minute or maybe after 30 seconds. There's no point, right? If it is gone, it is gone. So just like what Mr. Lias is saying, it is not maybe means I could able to understand only 60-70%, then there is some problem somewhere with respect to the packets. Packets are dropped somewhere, right? So overall, the point here I want to make here is that because of the queuing or because of the congestion on a particular router, there could be the case that the packet are going to be lost. Can we do something with respect to the packet loss? So suppose if I'm sending a layer 2 frame over this switch, and if switch finds that the CRC or the cyclic redundancy check or the frame check sequence is failed, right? Then the switch itself is going to discard this packet. It means the packet is lost. But we cannot do anything in this, right? If there is a change in packet, if it is not able to pass the FCS test, it is going to be discarded. There is no doubt about it. But we can do something with respect to when queuing happen for this packet, what packet we are going to drop, because this is in our hand. We can use our knowledge of transmission control protocol. We can use our knowledge of this queue and the packets. And if we have the overall understanding, then we can decide exactly which packets to drop so that it can lead to less destruction in my complete network topology, right? How we are going to see that, it is going to be really, really interesting. But for that, you need to wait till tomorrow. I hope this class was useful for you. And now for the next 15-20 minutes, I am here for any of your doubt, any of your question. Anybody? Okay, at least tell me that whether you can hear me or not. Anyone?
Hey, nobody's sleeping, everybody's listening.
How are you so sure, Mr. Guru?